In this video, I'm going to cover how to go about structuring an OmNext or Untangled application. I'm specifically going to be using Untangled because it does a lot of the back-end work for me, so I can show things more quickly. But most of the things I'm going to apply can be done directly with OmNext with just a little extra work in terms of setting up your application state. So here's what we're trying to build. We're trying to build an application that has some application root with some sort of navigation menu, maybe a top menu bar. I'm not going to do any CSS here. This is just going to be raw looking to start with, just to show the functionality. We're going to have some sort of top router that can switch us between a main screen, a login screen, a sign up screen, and a report subscreen. But the report subscreen itself might be a status report or a graphing report. So at any given time, any one of these five might be the main content area. Now, when you're designing applications in the large for Om, and therefore Untangled, your UI query pulls from the root anything the query says to pull. So if you compose all of these screens into a single query and then use UI logic to decide which to render, well then every time you re-render an animation frame, you'll pull the entire state of the UI even though you're only rendering part of it. So for example, if I joined this together as just a series of joins on main, login, sign up, status report, graphing report, I'd have this huge query. It would pull a huge amount of data and your frame rate would go to crap, essentially. So, because essentially you're saying select asterisk from asterisk. You're saying select everything from the world, pull that out of my app database. Oh, and then I'm only going to render this little thing over here. So this is where union queries come in handy, and that's why these parallelogram boxes are marked as unions. I need some component that takes a union query. And so you should have already watched the Getting Started videos and seen what a union query is about. Essentially, it lets you select at some point in your query to only query for one of the following, which is exactly what we want. At this place, we only want to call a query for main, login, sign up, or this nested report router that then will query for either only status report or graphing report. So then that keeps our UI query small as we update the screen, and therefore keeps our applications fast. So this is probably the biggest concern you'll have in structuring software of any size is putting together these union query components that act like screen routers. And again, you only end up with one of these on the screen at any given time. And if you have some subscreens, of course, you might have additional kinds of things where you nest these in to maybe render simultaneously on something. So for example, here we're rendering a nav menu in addition to a router. We could certainly put multiple routers in the same level as siblings so that two different portions of the screen we're rendering two different things, etc. So this is just, this composes however you need to compose it. So let's get started. The first thing we're going to do is we're going to build, let me pop over to my routing file here, just a few things. So we're just going to make some placeholders. So we're going to do a def UI on main, give it, and if you go back to the diagram that I'm showing here, main has an ident of main top, login has an ident of login top, sign, etc. So these are the idents of the leaf screens. I'll explain what's in the parallelograms here in a moment. So we want this guy to have an ident, but you see, since this is within a union, if you remember from your union tutorials, the component that's composed into a union doesn't need an ident function because the union itself will provide it. And so that's what this portion of the diagram is about right here. This is saying I'm going to pull the page from the properties of the thing I'm trying to render, and that's going to tell me which screen to render. So if I pull the props from app state and it says page is main, then I'm going to render main top. If I pull the page from the props of the object I'm trying to render and it's a login, then I'm going to show login top. So you can see here we're putting in the initial state of main that its page is main, and then we're just adding some label stuff. So the render's just trivial. There's nothing here to see other than we're making sure the initial state of this component will work with the ident function of the underlying router. Login, same thing. I'm just making sure page has login, everything's identical to main. It's just a lot of boilerplate. New user, same thing, page, new user. Now, when I get to the union itself has an ident of the components it's going to render. So this is, again, what's in the diagram here of how we generate the idea of which part of the query we're going to use when querying the UI. So this guy's going to pull the page from the props it finds in the UI and say, all right, that's which thing I want to query. And so the query right here, if page is main, then it'll use main's query. If page is login, then it'll use login's query, etc. So this is your typical union query. And then our render method just needs to decide, right, on the page, if the page, which comes in from the props again, right, we just programmed that right here, page, so it might be new user. If page is new user, then we'll call the renderer, which is just a factory. You can see that right here on a new user. All standard stock except for the fact in an initial app state's handled by Untangled. So Untangled is going to plug all these initial states and all the union branches into our app state for us, so we don't have to manually do it. So for example, when I start the application, it'll detect that I've got initial app state. It'll detect that I've already initialized this router with main, and it'll go find login and merge it into app state, and new user and merge it into app state. So everything's already ready to go. StockOM does not. StockOM Next does not do this. So this is an Untangled feature right here. But as far as the render goes, that's stock. The query goes, that's exactly what you'd write. The ident, that's exactly what you write. This is all standard OM Next. Okay, now we'd like to be able to tell this union what to do easily, and so we'd like to have some place to do that. It turns out that you can't use a union query all by itself. You have to use it with a second component that joins it in. Right, so you can't just have a query that you then use as your root that's a union. You have to have a separate component. And this actually serves us well. So top router here, this is what I'm calling this guy here, top router. Its initial state is just going to compose in, and it's just making this up. The current route is going to be whatever the top router union wants to do. So that'll end up giving you an ident here of this guy, which will be either main top or login top or new user top at this point. But I also want to give the top router component itself a separate ident so I can talk to it. So if I make top router have an ident of routers by ID, and then I just give it some ID, this is going to come in handy in a minute. And then of course my query, I need to mimic what I've done in my initial state. My initial state's going to have current route. That'll get normalized from this tree of data that's coming from top union, which is the tree of data that came from main by default, but then these other branches will end up in my app state because Untangled will do that for me, which is just a nice little handy extra feature. And then all I have to do is call the render of the union method with the thing I invented to compose the query. So I added that to the query as a join. I add it to my initial app state as just a value. I pull that out of my props and I call the renderer on that. So this is just essentially this is the pattern for doing these box parts with a router. That's the exact pattern. Now the reason I wanted to give this guy a routers by ID ident, now I'm going to compose this into top screen, and I might compose this top router anywhere in my application, and I don't want to have to worry about where it's at. That's why I want to give it an ident. I might move top router around. I might rearrange this whole hierarchy. It's something I might want to do in my application, and I'd like that not to break things. And Untangled and OM are perfect for that because everything you give an ident stays in the same place in the app database, and it doesn't care where you put it on the UI. You do have to compose it into the initial state so the graph gets formed, but initial app state makes that trivial. You literally just mimic your initial state as a map with the query that's got the data. But if I put this in an ident and I know current route is going to end up being normalized so that I'll see the ident of whatever screen I want here, well that means that in app state current route, and I can show you this if I log app state, my router's current route is right now login top, and we can see in the browser down here, let me shrink the diagram, well leave the diagram there. I'm currently on the login page. So that's routing me to that. And so this should immediately speak to you in terms of what it takes to now change pages. So over here in the username space, I've created a quick mutation. This is a route to mutation, and all it is an associn at that path, routers by ID, top screen, current route. right, where router is the router's ID, to some ident. So now if I want to transact, and here I'm transacting against the reconciler just to show you it working. If I want to go back to the main screen, I can transact there, and you see the UI updates down here to show me the main screen. If I look at app state, you can see that the routers by ID current route is now main top. So that makes switching a specific router trivial, and now I can compose them in any way I want, and all I have to know is the ID of the router or routers I need to change in order to make the application screen appear that I want to appear. Okay, so that's the base. And now we're going to clean this up and make it a little easier to deal with. All right, so we started out by making all of these by hand classes, and I'm going to leave main, I'm going to leave login, they're leafs, I'm going to leave new user, and this guy I'm going to get rid of. I'm going to get rid of top router union, I'm going to get rid of his render, I'm going to get rid of top router because these are all boilerplate. So I'm commenting these out. I'm going to get rid of UI top, and I'm going to get rid of root. So all this stuff, root I just made, actually root has a little bit of nav in it. I might want to keep that. Yeah, let's keep that. Let's keep that root. I have another thing I was doing here in a bit, but we'll keep it for now. And let's move it down here towards the bottom a bit, since it's going to be our root. Okay, and that's not compiling yet because I've got these other pieces commented out. So what I've done to make this a little easier to construct your applications, just to get this general hierarchy going, right? If you draw this out, you make a diagram, you decide, okay, here's what my application is going to look like. Well, it's kind of handy just to make some quick placeholders for these screens and then test out your routing and see that things work out nicely. So what I've done is over here in the macros namespace, I've created some quick macros that will emit these things. So I've got a def placeholder that will just emit a def UI that has a really basic state that you supply and whatever render body. So you supply just a render function. That'll make it gets rid of some of the boilerplate. I've generated a def mutation. We'll talk about that in a bit maybe. And then I've got some helper functions here, and then I've got another macro, def router, that emits the router and union element. So those two things that we just saw over here in routing, I just wrote a macro to make this, however many lines of code that is, from line 53 down to 83. Why not just have a macro spit that out? Because this is the only symbol that I care about, is top router. Almost everything else, except for what screens to put in here, right? I need to know what these screens are and what keywords go with them. Everything else is just boilerplate. So why not just make a macro that emits that? So now I can say def router, which is kind of nice. And then I also have a def root that will just emit a quick root element that can render one child and its initial state. So this is the one that I was thinking of using, but now that I've thought about it, I want to put my nav menu in my root. I probably don't need it. So let's go back, and we've got our pieces commented out that we were just using, and now we're going to uncomment a placeholder. So a placeholder takes a symbol that you want to define, its initial state, a render method that shows, in this case, just, it's a status thing, and this thing's showing that it's a graph thing. So we've got two placeholder pages. We're going to use def router to define those two extra components. We're going to give it the ID report router. We have to give an ident function, and you just form that just like you would with a def UI. And here we can see from the diagram that what we wanted for the report router was we want to get the page and the ID from the report we've routed to, so that we get to not only the correct renderer but the correct instance in app state of the report that we want to show. We're going to make a reports main, and we have to be very careful. This is our in this query, we need to make sure we query for the page or we won't get through correctly. I believe that's right. I put a comment there reminding me to say something about that, and I don't remember what the comment is, but we'll roll with it. So now we have some of these screens that we kind of manually generated. Up here we've got the main and the login and the new user still that are just, again, they're placeholders. We've got some easier placeholders now down here, a lot less code to write just to play with it until we get the actual thing we want written. report router takes an ID, an ident function, and then keyword pairs for the left side of the ident, because this is the thing that routes the which query to use, right? So we always need to supply that. We supply which is essentially which side of the query to use when we compose the query together, and then status report itself just needs to have something that's compatible with this ident function. So we're going to query for page, which better give us status report. This stuff has to match. And ID, which will fill in the right-hand side of the ident and tell us which report to go to. And so we're just having a report A and a status report A and a graphing report A. If we had other reports in our state, we would initialize their state separately, but we wouldn't need necessarily other renderings for them. And so now we can nest these things together. So do we still have report router reports main? Here's our top router. We're giving it the ID, so we're just repeating what we had here. Top router had an ID of top screen. So top router has an ID of top screen. We're just using def router now. We're copying the ident function. We're throwing together the 4 things that it should route between. Here we were saying def route on top router, and so let's just switch that to this guy so we save our navigation. And then we do have to make, we didn't make a top router factory. And since that's just a normal Omnext component, we can just pull the factory out of it, and we have UI top. We save that, and let's shrink this guy out of the way now so it stops going away. We'll reload to get our new initial app state. So now we can see that when we pull these graph in here, we should see status A as a report, login, new user. So even though my nav menu here is flat, I've got a separate router for this where the URI here could be status A, status B, whatever, and it would route to the same renderer with potentially different states in the UI for different reports. Okay, so let's talk about the routing. So again, I'm going to show you the app state. And so you can see I've got 2 routers by ID. I've got the top screen router who has a current route of login top, and the report router who has a current route of status report A. If I move to the status A link, you'll see that my app state changes so that the top route is report top. We can go look at that in the diagram here. So we're in report router. I'm sorry. Top screen's current route is report top is actually the ID of the reports main. Oh, right here. Yeah. Top router makes an ident function of something top, right? Always main top, login top, new user top. This guy happens to be, I didn't write it down, but this guy happens to be report top. So we gave him page report for this part of the screen, the report main screen, which then renders a report router underneath. So I actually am missing a little bubble in my diagram because this might have its own nav menu or extra UI stuff here. So that's why we're seeing reports main screen here. This is coming from the component that should be a bubble, essentially right here, a square. We're going to report top, which is then rendering potentially some sub nav menu, a search bar, whatever, and then there's a router underneath that to get you to the subscreens. But that screen itself doesn't appear in this diagram. I just elided something there. Okay, so you can see that the top router, the top screen router, is pointing to report top. Report top has its own state, so we can go and scroll up here and we can see report top has page report, and then it has a report router whose routers by ID report router. So we walk down to routers by ID report router, and his current route is status report A. So you can see, in the diagram, you can go back in the video or see here. We've gone to report top, which is a bubble here I didn't draw. This one got the ident from the state that was there, which then said status report A. So we're in a status report query, which gives us a specific instance, which then has an ID, and then this report can render it with whatever state happens to be there. And in our case, the state's just something we manually initialized. Status report A has page status report. There's nothing special in there. All right, so this dramatically simplifies these macros. You can do these sorts of things in closure and ClojureScript. It's just a handy sort of thing. Instead of writing all of this boilerplate, which amounted to about 80 lines of code, it can very quickly be compressed down to lines 87 through basically twice as much stuff with about the same amount of space, because we have the root in this one wouldn't count. We added an extra router, we added an extra 2 screens, and this, so the original code would have collapsed to 1 of those and 2 of those. So what was 87 lines is compressed down to about 12. So the power macros, and also this keeps you from making just getting these queries perfectly right and typing everything in and being able to extend them can be a little tedious, because each one of these adds something to the initial state, it adds something to the query, it adds something to the render. It's just easier to automate that into something that writes the code for you. Okay, now HTML5 writing. This is a really common question that I get asked, and so this video is going to talk about it. As you've already seen, even though we're not doing very nice on the CSS, we do have the URL here updating to indicate where we're at. And if I had the server serving these URLs as my index page, I could even go directly to them. But right now it's going to tell me I can't find the page because I haven't gotten my Ring server set up to do that. Basically, you want not found to serve your app, roughly. You might want to validate that the path seems reasonable, but other than that. Okay, so how do we hook this up? It's really very straightforward. If we go and look at down there and go hitting the need to fix the server. Okay, if I go in here and look at my core CLJS, what I've done is I've pulled in Biddy and I've pulled in Pushy. Biddy is a thing that can transform a data structure to routes and routes to a data structure, and Pushy is a wrapper around Google Clojure's history API, and so then you don't have to mess with all the events, etc. And so all you have to do is, and I'm storing the result of Pushy in a history object so that I have access to it. Pushy takes a function to call when a route needs to be set, and over here it takes another function that can match the route against what's incoming and give back the proper data to move you from piece to piece. So let me show you these pieces. App routes is something that you can look up in Biddy's documentation, and I'm using the verbose mode here. So I'm saying there's a branch at root, there's a leaf index HTML that I want you to render with the keyword main, basically give me main back as the handler for that. Same with indexed HTML. So here, if I'm in dev mode, I use this page. If I'm in production mode, I use this page, and this is so I don't accidentally hit the wrong JavaScript file or weirdness with compiles, etc. Just slash gives me the main. So if a leaf off of root is empty, that gives me main. If I see off of slash login, that should give me back the login keyword. Sign up gives me new user. Then I've got a branch here that's the status that requires a parameter, which it's going to encode as report ID, and then a leaf that's empty that gives me back the keyword status. So if I route to status A, what I'll get back from Biddy is this is the handler, and it'll put report ID in the handler params or in the route params of Biddy's response. So this lets you set up your hierarchy to map URIs out to that diagram. So let me go back to the setup there. So this is one part. Set route is I've just encoded that as a transact against a component or the reconciler that calls this mutation to update the route, and it just passes the Biddy match in as a parameter. And this map is going to have 2 elements to it, the handler and the route params. And so you can see I'm doing a partial here to hook it up to the reconcile that I'm getting in the started callback. So I don't want to hook up pushy until Untangled's running, because it's going to look at the URI and send me an event. And so I want to make sure the UI is on the screen and ready to go when I do pushy start. And then if for some reason I need to grab hold of the history object and tell pushy I want to set the token or something, say for debugging or playing around, I can do that as well. So that's all it takes to set it up and start it. And then we have to write set route. So I've written set route to use this update route mutation. And you can see update route here is a really simple mutation. It basically pulls the entire parameter set off and passes them through a swap on state to this function, update routing links, where p is the only parameter. And then update routing links is a little bigger, but essentially all it does is go through and switch all the train switches using this data structure. So here's the idea: is if I encode a routing tree with the keywords that I've programmed into Biddy. So Biddy, remember, I've got the handlers. I'm going to get main or login or new user or status. And this is the only keyword I'm going to get. I won't get a whole tree out of this. I'll just get, you're on status. That's where you're supposed to be. And so in order to get to status, if you remember by looking at the app state, in order to get to status, I have to make sure that this router is pointing to the reports. I'm sorry, what am I trying to get to? Yeah, the status report. I'm pointing at the report piece, and that this other router is pointing to which report I want to be on. So I have to actually switch two routers, and remember that this one's an ID. So I'm allowing a little bit of extra stuff here. So report ID is the name of the parameter I gave for this guy. And so I've invented a data structure that says when I see this from Biddy, I need to switch these routers to these idents. And in the idents, I allow in either position a namespaced keyword with the param namespace and the Biddy value, and I'll essentially extract that from what Biddy told me and replace it in this ident before writing this ident into app state. So that's what this function does. So this function just pulls out from the parameters coming in, route params and handler, and then in this data structure in the routing tree, it says whatever the handler was, that's just a keyword, get that out of there. And if I get something that I don't expect, all right, I don't have a path. I don't have a map of things to do, essentially. So this reduce then won't do anything, because the reduce is going over the path map. So normally I would get one of these entries, like I might get this map as my path map. So I just reduce over that. And remember, this is going to be happening on a swap. And the reduce basically uses a map v, which is non-lazy, to do what I say. Replace the parameter keywords with things that I find in the route params. That gives me the value that I want to source at the router. So routers by ID, router ID. We saw this earlier in the talk. Current route, and then this value is just the one of the idents in that path map that needs to be set. So this, I kind of think of it in my head as kind of a bunch of train switches, right, in that diagram as you walk from, I closed it. As you walk from piece to piece in that diagram, you're just kind of train switching the pieces that need to be in place in order to see what you want to see. So this gives you a declarative way of saying, what the different screens are in your application and how to route to them over those router components. And then this is what you end up with. The next thing I should mention is there are a couple of ways of navigating to these. So once Biddy is started, you can actually use hrefs, which is what I'm using right now, to navigate. The problem with that is now you're using HTML5 routing, and if you try to embed this in a dev card, which also uses HTML5 routing, you're not going to be able to play with it there. It'll actually change the URI, and then dev cards will lose its mind. However, the routing as you've seen it in terms of switching these little train switches to point to the new screens will work just fine. So instead, what you might want to do is, and I've done this here for new user and login as alternatives, is define some function nav2 that decides, or that just does the essentially the logic, And then within that logic, you can check to say, all right, well, if there's a history set up and I'm supposed to use HTML5 routing, then set the token. Setting the token will trigger a BIDI event, which will cause it to do the update route. And if you're not using HTML5 routing, well, just update the route directly. Right? And so that'll keep the URI updates from happening. So this is really handy if you want to embed it in a dev card. You can just change this atom at the top of your dev cards file to false, and then it'll just use the internal routing and it won't muck with the URI. Whereas you can default this guy to true so that when the application's running in the wild, it works just fine.